it will be same 100 Mbps megabit per second. Okay. Okay, so how to verify your QoS type? So face F 0 slash, sorry, serial 0/0. So you can see here by default it is weighted fair queue. Okay, so this is how it works, and let's see what we have in fast Ethernet port. So you can see the difference between weighted fair queue, sorry, your fast Ethernet and serial interface. So fast Ethernet by default using FIFO, first in first out, which is your default method, and serial interface is using your weighted fair queue. Okay, so last time I also described that if you are having less bandwidth, less than 2 Mbps or something, it will have weighted fair queue as a default QoS mechanism, and if you have a higher bandwidth, and then it will have FIFO as a default QoS. Okay, so let's say I'm having, okay, so let's say this is a subnet. Okay, so first step will be my, if I'm using a class access list to categorize your subnet, so create an access list. It depends on the standard and extended, so let's say I'm creating access list as standard access list, then it should be always permit because we are matching the traffic. So access list will not take any decision over here, so there should not be any decision making like deny or anything. Okay, so it should be always permit 192.168.1.0 and then your wildcard. Okay, second step, create class map. Match any and then your class map name. To identify what name you are providing, always use caps, uppercase. So let's say it is my VoIP, right? Then under the class map, it shows CMap. You can define match and various options. So in various option you can use access group, then or name, it depends on you. Okay, then third one will be policy map, where you will call policy map name, let's say priority. In PMAP you can use class, and the class which you have created, it should be case sensitive. Wipe, okay, and then you will be in a different prompt, PMAP C something. Here you can set DSCP EF priority percent whatever. So this will be your third step in this scenario. I'm including this extra. Anyway, it's a first and second. So basically, let's say first and second. And third, apply it on interface. So let's say I'm applying it on the WAN interface, outgoing interface serial 0/0 service policy out, and then policy name priority. Okay, so these are the steps. Okay, so let's talk about some QoS mechanism which we have in Cisco IOS. FIFO. So FIFO queuing is an effect by default in the higher bandwidth traffic, sorry, interfaces. Traffic which is the order of the traffic will be first in, first out. It is just providing the queue size to you guys. You can define the queue size in FIFO basically. So the group of packet which is receiving first, that will be moved together to the next level, or basically in physical media. Second one is Faire queue. So we don't have anything special in FIFO to describe. Even if you want to enable FIFO in serial interface, you can use that. No Faire queue. This is right. So let's see, do show interface F serial 0/0. So it should come to the FIFO now. Yeah. So QoS strategy, it's FIFO now. Okay. So this is the one, weighted or Faire queue. So basically, so second method is Faire queue. Okay. So basically, Faire queue is not supported in Cisco router. It allows packets that are ready to be transmitted to leave even if they started to arrive after another packet. Okay, so let's say if I'm having a queue. So basically one physical interface will have a specific buffer size, and that is called queue, I would say. So let's say this is my tunnel, or this is my buffer size. I have received a packet, but it's not complete packet, so I'm waiting for another segment. And even I have received, so this is the first packet, but in next order I have received another packet which is complete. Okay, so it will send this packet first. It's ready to be transmitted. Okay, so it complete the packet that are ready to transmit and leave first. So packet may enter output, the output buffer from variety of input interface. Okay, so suppose this is the half of the packet and then it received another half of the packet, so then it will transmit that. So this is simple Faire queue. Another one is weighted Faire queue. This is default in Cisco. Again, WFQ. So weighted Faire queuing. So weighted Faire queuing is an automated method that provides fair bandwidth allocation to all network traffic. Okay. So let's say if I'm having this one. This is my router. I'm receiving traffic from different source. Let's say that the traffic from this PC is packet 3. This PC is sending 4 and 5. This PC is sending 1, 2. Okay, so the packet which is receiving I would say the packet which is in smallest size, that will be forwarded first. Okay, so this will go exit first 3. So basically it categorizes the traffic in the behalf of size of packet. So small packet in low volume, even it arrives later, it will be given the prioritize. Okay, uh, provides traffic priority management dynamically, sorts traffic into conversation or flows, will be given the priority, break up the packet size, packet stream, and each conversation ensure packet is shared fairly between the individual conversation. So if you are receiving a different conversation with the same traffic, same type of traffic, it will be given the same priority. The the motto of this one, that low size traffic will not be denied or dropped because of bursty traffic like FTP or some other traffic. Like if you are sending the telnet or FTP at the same time, so telnet will be served first. Okay, weighted Faire queue, again we don't have too much to do with that. It's by default enable, and weighted Faire queue. Oops, 0 slash. Yeah, any question?